In topic 6.2, we're going to learn the properties of rhombus, rectangles, and squares. For today, we're just going to focus on rectangles. So rectangles have all the properties of parallelograms where opposite sides are parallel and congruent, opposite angles are congruent, consecutive angles, or the angles that are side by side, are supplementary or add to 180, and the diagonals bisect each other. But in addition to those properties, they also have the properties that all the angles in the corners are right angles. So all the angles are 90 degrees. And each diagonal as well is congruent. So not only do they bisect each other, but they're congruent. So all four pieces of the diagonals that you'll see will be congruent as well. Keep in mind as well that because it's a rectangle, it divides it into isosceles triangles. So since the triangles are isosceles, the two base angles of each of those triangles as well is congruent. So one of those little angles is congruent to the other one. We're going to use these properties to help us answer some questions. So first, let's do a simple problem without algebra, where we're just finding the measure of angles. Here we know that the measure of angle 1 is 50 degrees. So if I wanted to find angle 2, I know that angle 1 and angle 2 together form a right angle. So they form 90 degrees. So to get angle 2, I would subtract 90 minus 50 and get 40. So angle 2 is 40 degrees. And since I know that this is an isosceles triangle, angle 2 and angle 3 are going to be congruent. They're going to have the same measure. So angle 3 is also going to be 40 degrees. So angle 4 then would also be 50 degrees, because 40 plus 50 would give me the 90. And we know the corners form a right angle. For angle 5, if we compare it to angle 2, we'll find its measure. So what I mean by that, let me erase a little bit here. Angle 2 and angle 5 are alternate interior angles, which you learned about in chapter or unit 3. And we learned in unit 3 that alternate interior angles are congruent. So angle 2 and angle 5 are alternate interior angles, and so they're congruent to each other. So since angle 2 is 40 degrees, angle 5 is also 40 degrees. Since we know this bottom piece makes an isosceles triangle, angle 5 and angle 6 on that triangle are congruent. So angle 6 is also 40 degrees. Angle 7 makes a right angle with angle 6, so it would add up to 90 degrees. So this piece is 50. Also, we know that because here angle 1 and angle 7 are a little isosceles triangle as well. So together, these two angles are congruent. Now, if I want to know the measure of angle 8, I know that 3 angles in a triangle add to 180. So this is 40 and this is 40. If I want to know the measure of angle 8, I can add 40 and 40 and subtract those from 180. So angle 8 is 100 degrees. If I wanted to know 9 and 10, there was different ways to do it. For example, if I wanted to know angle 10, I know that these two angles lie on a line, so they're going to add to 180. So this is 100, and I do 180 minus 100. I get 80 degrees for angle 10. And since angle 9 and angle 10 are vertical angles, angle 9 must also be 80 degrees. Again, there's different ways I could have done that. I could have also said these two angles are 50, so if I add those, I get 100. If I subtract from 180, I get 80. So different ways to work out the angles in this triangle. The important thing to know, though, is that each of those little triangles are isosceles, So the base angles are congruent. And then we also know that in a triangle, the corner angles add up to 90 degrees. So those are just some important things here that we use to help us with the angles. As well, if you remember from chapter 3, we learned about alternate interior angles. So alternate interior angles as well are congruent. We're going to now look at some problems where we use algebra. So here, since we know this is a rectangle and has the properties of parallelograms, opposite sides have to be congruent. So here I could say 7x minus 4 equals 6x plus 4, and then I could use that to solve for x. Here, I'm going to solve for x first. So I know these two angles together form a 90-degree angle. So what I can do is I can add 5x plus 8 plus 3x plus 2 and set it equal to 90. So now I'm going to make this smaller if I combine like terms. 5x plus 3x is 8x, and 8 plus 2 is positive 10. So I can finish solving for x there. Now, I'm going to plug this back in to my angles. So here, if I plug in 10 for x and work it out, 3 times 10 is 30, plus 2 is 32. So this little angle is 32 degrees. If you look at the angle that has y, it's actually alternate interior to this angle down here. So since they're alternate interior, they're congruent. So 6y plus 2 is going to equal 32. And I can use that equation to solve for y. In my next image, I have a rectangle. They're saying PS, so diagonal PS, this one here, is 6x plus 3. And our T, this one here, is 7x minus 2. Since we learned that the diagonals of rectangles are congruent, I can set those equal to each other. And then I can continue to solve for x. In our next image, we have diagonals as well. We know that the diagonals not only are congruent, but they bisect each other. So all these pieces are going to be congruent here. So we can set 2x minus 4 equal to 36, and then use that to solve for x. So here we're just using several of the things we learned. Here we know that the diagonals are congruent. So that's why I could set that equation. Here we know that each piece, they're all bisected. So they're congruent as well. Up here in this example, we know that alternate interior angles are congruent. We also know that the corner adds up to 90 degrees. Here we know that opposite sides are congruent. So we're just using different things we learned about rectangles and parallelograms to help us solve these problems.